As we speak, the night sky is undergoing profound changes that will transform its appearance within decades, if not years. Experts and astronomers around the world have raised the alarm. Personalities such as Neil deGrasse Tyson have collaborated, stating that Polaris is about to undergo a drastic change, and the story behind this event is disturbing. Polaris's central position in the night sky has defined its uniqueness as the North Star. Until now, this star was a constant reference point for stargazers, navigators, and astronomers. However, this stability could soon be altered significantly, transforming both our night sky and the astronomical measurements we are accustomed to. Join us to understand the seriousness of this threat and its impact on all of us. Let's examine the history of Polaris, which is in its final stages. Polaris has long been considered the guiding star that leads the way, a beacon revered by astronomers and navigators throughout the centuries. Its constant presence in the firmament has been fundamental to celestial navigation. However, all this could suddenly change. A recent study presented by the respected Royal Astronomical Society in September 2023 has raised uncertainty about the future of this bright star. Polaris is on the verge of an explosion that will cause it to disappear permanently from the night sky. Before we delve into the implications of this revelation, let's take a closer look at the star in question. Polaris, also known as the North Star, occupies a special position in the sky because of its proximity to the celestial North Pole. It is almost directly over Earth's North Pole, which gives the illusion that it remains static in the northern sky. The star is located in the constellation Ursa Minor. Polaris is a star of moderate brightness that stands out as a yellow-white supergiant of considerable dimension compared to our Sun. Despite its appearance as a lone star, it is actually part of a rather complex triple star system. Within this system, the primary stars are Polaris Ia and Polaris Eb, which seen with the naked eye look like a single star. In addition, there is a third companion, Polaris B, orbiting this binary pair. The gravitational forces between these stars shape their orbits and affect their individual behaviors, which has a direct impact on their brightness and other notable characteristics. Polaris is approximately 323 light-years from Earth, which means that the light we receive from this star today was actually emitted 323 years ago. This great distance means that if Polaris were to explode today, we would not be aware of it until 323 years later. Therefore, when we finally witness this event from Earth, more than 3 centuries will have elapsed since it occurred. The scientific projections are based on the empirical evidence available at present, which implies that it is plausible that Polaris has already experienced an explosion, but we have not yet received the light from that event. Throughout history, the North Star has played a significant role extending through various civilizations and eras. Its value is cultural, symbolic, and crucial to navigation. Its stability and immovable position near the celestial North Pole have made it an invaluable tool for ancient mariners and travelers. This star has acted as a lighthouse, allowing precise orientation and navigation, especially in the northern hemisphere. The North Star holds great symbolic importance in all cultures. In some social groups, it represents the idea of constancy and solidity, perceived as a pole star, an element that has remained unchanging amidst the celestial ballet that makes up the night sky. Recently, this star has exhibited behavior out of the expected. This disturbing alteration in its pulsation cycle has posed a challenge to astronomers, prompting further analysis of the celestial anomaly. Instead of following the predictable pulsation pattern, Polaris has adopted an unpredictable and erratic cycle of dimming and brightening. This variation has raised concern among scientists who warn that the star may be nearing the end of its life. This change is consistent with the behavior observed in stars as they near the end of their existence. The progressive increase in the pulsation times of Polaris, which was previously stable in its dimming and brightening cycle, could be attributed to the interactions between the star and its system, even though they are perceived as a single entity. Notably, we have observed an unusual increase in pulsation duration of approximately 4.5 seconds. Although seemingly insignificant, this change is of great significance. Some astronomers have cautiously suggested the gravitational forces between Polaris's stars could be the cause of these fluctuations in the star's atmospheric conditions, directly affecting its pulsation patterns. However, Others are not convinced and firmly believe that the star is close to its explosion. This suspicion is based on the striking similarities between the mysterious behavior of Polaris and Betelgeuse. Betelgeuse, another prominent star in the Orion constellation, has shown puzzling alterations in its brightness, leading to speculation about a possible imminent explosion. Several experts have warned of the star's inevitable end, emphasizing abrupt fluctuations in its brightness and behavior pattern, similar to those of stars that have reached the end of their life cycles. NASA was attracted by the anomalies presented by Betelgeuse. The agency has shown great concern about the possibility of Betelgeuse exploding, which contrasts with the irregularities observed in Polaris. Although NASA has expressed strong interest and vigilance towards the unusual behavior of Betelgeuse, it has not made an official announcement of similar monitoring concern regarding Polaris. Stars undergo extensive journeys through different stages in their evolutionary cycles. When new, these stars have relatively low temperatures and brightness. Subsequently, they advance to the main sequence phase, marked by nuclear fusion, where they remain stable for billions of years. Finally, as their hydrogen fuel is depleted, they enter the red giant phase, where they experience a rapid increase in temperature and brightness. This phase sees a dramatic increase in energy output before reaching a catastrophic explosion. If Polaris were to experience a supernova, we would surely witness an amazing event in our sky. The star would become incredibly luminous, eclipsing even the brilliance of the moon and becoming one of the brightest objects in the night sky. This luminous spectacle could last for days, weeks, or even months. The star's visual appearance would undergo drastic changes. It would transform into a dazzling point of light or a temporary bright object, potentially manifesting colors before fading. This visual display could momentarily alter our familiar perception of the constellation Ursa Major or Ursa Minor, since Polaris is actually the North Star and is part of these stellar groupings. As for our safety, we would be completely safe. Given the size and distance of Polaris, it is likely that the Earth would not be affected even in the event of a stellar explosion. Visually, although a Polaris supernova may not be as spectacular as Betelgeuse, it could be visible to the naked eye for a long period and outshine nearby bright stars. The potential supernova of Polaris would mark a significant event in astronomical history, offering scientists a rare opportunity to observe and study the dynamics of a star's explosive demise up close. Despite its current stability, Polaris's irregular pulsation patterns and the gravitational interactions within its triple star system hint at an impending change. Astronomers continue to monitor its behavior closely, seeking clues that could shed light on when and how this celestial transformation will unfold. The unique position of Polaris as the North Star makes its future even more impactful, potentially altering millennial navigational traditions and cultural symbolism across civilizations. Polaris, known scientifically as Alpha Ursae Minoris, has been a steadfast fixture in the night sky for millennia. It sits almost directly above Earth's North Pole, making it a pivotal celestial reference point for navigators and astronomers alike. The star's proximity to the celestial pole gives it the appearance of remaining stationary as the Earth rotates, providing a constant marker in the northern sky. This stability has earned Polaris a prominent place in human history and culture, where it has been revered as a guiding light amidst the vast expanse of the cosmos. The scientific interest in Polaris extends beyond its navigational utility. As a star nearing the end of its life cycle, Polaris presents a unique opportunity to study stellar evolution and the processes that govern the birth and death of stars. It belongs to the class of Cepheid variable stars, known for their periodic pulsations in brightness. These pulsations are linked to changes in the star's size and temperature, providing astronomers with valuable insights into the internal dynamics of stars. Recent observations and studies have revealed unexpected behavior in Polaris's pulsation cycle. Instead of following its typical pattern of regular dimming and brightening, Polaris has exhibited irregular fluctuations in brightness. This variability suggests underlying changes within the star, possibly indicating instability in its core processes. While such fluctuations are not uncommon in variable stars, the implications for Polaris, given its status as a North Star, are profound. A pivotal moment in the study of Polaris came with a study presented by the Royal Astronomical Society in 2023, which raised significant questions about the star's future. The study suggested that Polaris may be approaching the end of its life cycle and could potentially undergo a supernova explosion in the near future. This revelation sparked intense scrutiny and renewed interest in the star's behavior, prompting astronomers worldwide to intensify their observations and analyses. Understanding the potential supernova of Polaris involves delving into the intricate dynamics of its stellar system. Polaris is not a solitary star but rather part of a triple star system consisting of Polaris AA, Polaris AB, and Polaris B. Polaris AA and AB form a binary pair closely orbiting each other, while Polaris B orbits this binary pair at a greater distance. The gravitational interactions between these stars influence their orbits and behaviors, contributing to the overall stability or instability of the system. The complex nature of Polaris's triple star system adds layers of complexity to predicting its future. While Polaris AA and AB are the primary contributors to Polaris's brightness as observed from Earth, the presence of Polaris B introduces additional gravitational influences that could perturb the system. Astronomers hypothesize that these interactions may be responsible for the recent irregularities observed in Polaris's pulsation patterns, indicating potential changes in the star's internal structure. Theoretical models of stellar evolution suggest that stars like Polaris undergo significant transformations as they approach the end of their lives. Initially, Polaris would have been a relatively cool star, gradually transitioning to the main sequence phase where nuclear fusion in its core sustained its brightness and stability for millions of years. However, as Polaris exhausts its hydrogen fuel, it enters the later stages of stellar evolution characterized by dramatic increases in temperature and brightness. The red giant phase marks a critical stage in a star's evolution, where it expands to several times its original size, becoming thousands of times more luminous than in its earlier stages. For Polaris, this phase would signify a notable increase in its energy output, potentially leading to observable changes in its appearance from Earth. The star's increased luminosity could make it appear brighter and more prominent in the night sky, altering its role as a navigational beacon and cultural symbol. Beyond the red giant phase lies the eventual fate of stars like Polaris, the possibility of a supernova explosion. Supernovae are among the most energetic events in the universe, releasing vast amounts of energy and matter into space. When a massive star exhausts its nuclear fuel and can no longer sustain the fusion reactions that support it, gravitational collapse triggers a catastrophic explosion. This explosion, visible across vast distances, can temporarily outshine entire galaxies and leave behind remnants such as neutron stars or black holes. If Polaris were to undergo a supernova, astronomers predict that it would become one of the brightest objects in the night sky, potentially rivaling the brilliance of the moon. The sudden increase in luminosity would be accompanied by dramatic changes in its visual appearance, transforming Polaris into a dazzling point of light or a temporary bright object visible to the naked eye. Such an event would not only captivate astronomers but also provide valuable data on the final stages of stellar evolution. The study of Polaris's potential supernova is not merely academic but holds practical implications for Earth and its inhabitants. Despite its celestial significance, the explosion of Polaris would pose no direct threat to our planet due to its immense distance from Earth. The star is located approximately 323 light-years away, meaning that any effects from its supernova would be limited to the observable light and radiation emitted during the event. From a scientific perspective, the supernova of Polaris would provide a unique opportunity to study the physics of supernovae and their impact on surrounding space. Astronomers would observe the evolution of the explosion from the initial burst of light to the formation of nebulae and remnants that continue to expand across the cosmos. These observations could yield insights into the origins of elements essential for life, such as carbon, oxygen, and nitrogen, which are forged in the intense heat and pressure of supernovae. Moreover, the supernova of Polaris would have broader implications for our understanding of the universe's structure and evolution. By studying how stars like Polaris end their lives, astronomers can refine models of stellar evolution and improve our predictions of how galaxies, including our own Milky Way, evolve over billions of years. The remnants left behind by supernovae play crucial roles in the formation of new stars and planetary systems, shaping the cosmic landscape we observe today. The cultural and historical significance of Polaris further underscores its importance in the study of astronomy and human civilization. For centuries, Polaris has guided travelers across oceans and deserts, serving as a reliable reference point for navigation and exploration. Its constancy in the night sky has inspired myths, legends, and scientific inquiry, symbolizing the enduring quest for knowledge and understanding of the cosmos. In ancient times, Polaris held spiritual and navigational significance for civilizations around the world. In Norse mythology, Polaris was associated with the god Odin, who was believed to guide souls to the afterlife. In Chinese astronomy, Polaris was revered as the central star around which all other stars revolved, symbolizing order and stability in the heavens. Across cultures, Polaris has been a symbol of guidance, leadership, and the unchanging principles that govern the universe. The potential loss of Polaris as a visible star in the night sky would mark the end of an era in astronomy and cultural heritage. Its absence would not only affect navigational practices but also alter our perception of the cosmos and our place within it. The constellations Ursa Major and Ursa Minor, with which Polaris is closely associated, would lose their guiding star, reshaping the narratives and interpretations that have persisted for centuries. While the future of Polaris remains uncertain, ongoing observations and research efforts are aimed at unraveling the mysteries surrounding its behavior and predicting its fate. Advanced telescopes and observational techniques enable astronomers to monitor Polaris's brightness, spectral characteristics, and pulsation patterns with unprecedented detail. These observations provide valuable data points for theoretical models and simulations that simulate the conditions within Polaris and predict its future evolution. The study of variable stars like Polaris is part of a broader effort to understand the diversity of stellar phenomena and their impact on the universe. Variable stars exhibit changes in brightness over time, offering insights into the physical processes occurring within stars and their evolutionary paths. By studying these changes, astronomers can classify variable stars into different categories based on their behavior and identify underlying mechanisms driving their variability. Polaris's status as a Cepheid variable star places it among a class of stars used to measure distances in the universe. The relationship between a Cepheid star's period of pulsation and its intrinsic luminosity allows astronomers to calculate its distance from Earth with high precision. This method, known as the cosmic distance ladder, forms the basis for measuring distances to galaxies, clusters of stars, and other celestial objects across vast cosmic scales. The accuracy of distance measurements derived from Cepheid variables like Polaris has far-reaching implications for our understanding of the size, age, and expansion rate of the universe. By calibrating the cosmic distance ladder with precise measurements of nearby variable stars, astronomers can refine their estimates of the Hubble constant, a key parameter that describes the rate at which the universe is expanding. These measurements contribute to cosmological models that trace the evolution of the universe from its early beginnings to its current state. In conclusion, Polaris occupies a unique position in both the night sky and human history, embodying the enduring quest for knowledge and understanding of the cosmos. As a Cepheid variable star nearing the end of its life cycle, Polaris offers scientists a window into the processes that shape the birth, life, and death of stars. The potential supernova of Polaris represents not only a scientific milestone, but also a cultural and historical turning point, reminding us of our place within the vast and ever-changing universe.